In fact, NASA is planning a mission called the Jupiter Icy Moons Orbiter, aka JIMO. At 120 feet long, it's going to be several times larger than any planetary probe ever launched, and its nuclear reactor will power ion engines and a big science radar. The main goal of JIMO will be to use that radar to look down through the ice of Jupiter's 3 largest moons. First, it will study Callisto, and then it'll move to Ganymede. And these are bizarre moons, the largest of Jupiter's 61 known moons. Callisto and Ganymede both have crusts of ancient ice and rock that may hide oceans miles below the surface. Further in is Io, which is a moon of fire, not ice. Io's eccentric orbit causes it to deform as it circles Jupiter. This intense tidal pumping pulls at the moon like taffy, generating friction at the core, which then becomes heat, and this heat drives the solar system's largest active volcanoes. There are constant eruptions, rivers of lava, and volcanic plumes shooting hundreds of miles into space. But the gem of the Jovian system, at least as far as the search for life is concerned, is Europa. It's here where fire and ice come together in perfect harmony. The scientific community is relatively certain that beneath the icy, chaotic shell of Europa, there exists a liquid water ocean with twice the volume of all the Earth's oceans combined. So tidal heating is working here too, keeping that water from freezing, and possibly providing energy for life, the same kind of life that we're finding at the deep vents here on Earth.
A mission to explore under the ice of Europa would be the ultimate robotic challenge. During the landing, the team in mission control would pretty much be along for the ride. Europa is so far away that even at the speed of light, it would take more than an hour for the command just to reach the vehicle. It's really on its own. It has to be smart enough to avoid terrain hazards and to find a good landing site on the ice. Now we have to get through the ice. You need a melt probe. It's basically a nuclear heated torpedo. The ice could be anywhere from 3 to 16 miles deep. Week after week, the melt probe will sink of its own weight through the ancient ice. Until finally, now, what are you going to do when you reach the surface of that ocean? You need an AUV, an autonomous underwater vehicle. It needs to be one smart puppy, able to navigate and make decisions on its own in an alien ocean. Europa has internal heat. It may well have hydrothermal venting. If it does, and if the chemistry is right,
it will have an enormous impact on humanity if we find life in an ocean on another world.